Hi, today's video will be on accuracy, precision, and error, brought to you by McQueen and friends. This is Sabrina. I'm surprised she made it to class. And this is Belle. She'll be helping Sabrina get through the day. And here is Dylan, star student staring out the window for no apparent reason. And I'm Max. I'll be your narrator because I missed filming day. Right now, both Dylan and Sabrina need to measure 10 mLs of water. Sabrina has chosen to use a 50 ml beaker, and Dylan has chosen to use a 10 ml graduated cylinder. Now let's see how Sabrina's measurement compares to Dylan's. As we can see, Sabrina's choice is quite inaccurate. Don't be Sabrina. Make sure to choose the appropriate glassware in accordance with the procedure to maximize accuracy and minimize your error. The way to enhance accuracy when measuring liquids is to read the quantity properly. Let's take a moment and look at this picture. What's wrong here? That's right, somebody let Sabrina measure the water again. More importantly, Sabrina isn't reading the graduated cylinder properly, thus compromising the accuracy of her measurement. She needs to get down to eye level to read the bottom of the meniscus for an accurate measurement. Now moving on to accuracy versus precision. Here, Belle needs 3 allotments of 20 mLs of water. Unlike Sabrina, she's actually going to use a graduated cylinder. But for some reason, she only measures out 18 mLs each time. Her measurements are all 18 mLs, so they are precise because they're all the same volume, but they are not accurate because the intended volume was 20 mLs. Now on to titrations. If you understand acid-base chemistry, you'll be able to figure out how the titration errors will affect the pH of the equivalence point. If you don't add enough titrant, the color from the indicator fades into clear, which makes the calculated equivalence point way too low. If you add too much titrant, the color of the solution is too dark, so the calculated equivalence point is too high. Now, if you add just the right amount of titrant, the color of the solution will be light, just like this. Now your calculated equivalence point will be close to the literature value, as long as you pick the right color indicator. How do we know which indicator to use? Well, when choosing an indicator, you want to choose one that has a pKa close to the pH of the equivalence point of the reaction. So here are some different indicators and their pKa's. For our specific titration, our equivalence point should be around 7. So which indicator should we use? This one? Or maybe the blue one? Or that one? Or this gross color? Yeah, that's right. It's this one. Choose the one with a pKa of 7.2. Now on to accuracy using glassware. When using glassware in lab, it's important that there are no traces of previous chemicals that might be left behind by improperly cleaned glassware. Cleaning glassware is necessary because college students are gross and spread HFM. More importantly, it's necessary when preparing solutions with specific molarities. Contamination from unclean glassware can result in a solution that does not have the intended molarity. This can skew data, and calculations later on in the lab might be messed up. Now let's take a look at contamination with pipettes. When measuring out different solutions using a pipetteman, you must make sure not to use the same pipette tip. Right now, Belle is pipetting solutions into cuvettes to measure their absorbance spectra. Any traces of different solution will skew Belle's absorbance data in her future calculations. Wait, Belle! You need to change the tip! Ah, thanks, Sabrina. You finally did something right. Now on to errors of the filter funnel. In the liquid crystal lab, we used a vacuum filtration system to separate precipitate from the solution. Any precipitate left on the filter paper was practically lost. This loss of precipitate results in a decreased calculated percent yield. When it comes down to random error, it's really important to note the sources of error within your materials. This includes all of your glassware, all of their serial numbers, and even the temperature of the room. Yeah. Also, don't forget to write down the error associated with each measuring tool. Scales and glassware can only measure up to a certain degree of accuracy. If anything drastic comes up later, you can look back at this as a possible source of error. If there is any error printed on the glassware, then just take a look at the lines. The difference between the lines divided by 2 will be your error. For this 10 ml graduated cylinder, it will be 0.05 mLs. On one last note, let's see how preparation affects our labs. Let's take a look at Dylan. Dylan is prepared. He highlighted his lab handout. He did the pre-lab. He wrote his equipment out before the lab, and he even arrived 10 minutes early. Now, let's look at Sabrina. Sabrina slept in. Sabrina's my lab partner. Don't have Sabrina as your lab partner.
And don't forget, if you have any questions, come to your TA or Professor McQueen for help.